Hello, sir. Hello, Sir Sana. This is Jason A.P. Contipan, a Master of Arts in Education, major in Mathematics student. So here I am to present my work about tautologies and contradiction. So let's start. So first and foremost, let's recall on our knowledge on what is a tautology and what is a contradiction. So based on what we had discussed in the past lessons, tautologies is all about these are statements that whatever valuation that we assign to a certain statement, the resulting statement, the resulting compound is always true. While the contradiction is same with tautologies, and what makes it different is that the statement or the resulting compound statement is always false. So now let's identify which of the following compound statements are tautologies and which of the following are also contradiction. So let's try first the item number one. Let's construct first a truth table. So let's say this is P and this is Q. And we know already how to assign truth values on each statement. So for P, let's say this is true, true, then this is F, false, false. Then for the Q, let's say this is T, this is F, this is T, this is F. So let's now solve for the P or Q. P or Q. So we know pretty well that the disjunction operation in constructing a truth table, the resulting compound statement will only be false if and only if both of the statements being disjunction are false. So only the fourth statement is false and the rest are true. And now finally let's have the final statement, the P implies P or Q. Okay, so what are we going to watch for it or to see for, to look for is that our P only and the P or Q. Now, let's try to first solve the P, the first, the true and the true. But before that, we shall recall that when a function is talks about the implication, the resulting compound statement will only be false if the first statement is true and the second statement is false. So let's solve. Let's try to look for the look for the truth value of the resulting statement. The true or true, the true and true. P implies true, true implies true, this is true. True implies true, this is true. False implies true, this is true. But if it is true implies false, this is false. But since it's false implies true, then this is true. False implies false, this is still true. So we can now conclude that this resulting compound statement or this statement is a tautology based on the definition that I have given a while ago. So now we already have one tautology statement for number one. Let's try to identify the second statement if it is tautology or a contradiction. So let's construct a truth table. There's a P here, P, F, F, P, F, P, F. Then let's look for the truth value of P implies Q. Remember that the P implies Q will only be false if the first statement is true and the second statement is false. So only the second statement is false. True. Then the rest are true statements. While the third one, it is the AND operation. Take note that the statement or the resulting compound will only be true under AND operation if and only if both of the statements are true. So, the first statement, let's look for the P implies Q and P. That's here and here. So, the T and T, that's T. How about the T and F? This is F. And for the F and T, this is still F. And F and T, this is still F. And now let's move to the resulting statement or the final statement. The P implies Q and P implies Q. So what are we going to look for is the truth value of, first is this one. So mark this first because the truth value of the resulting compound statement depends on the truth value according to what comes first. So the second one is the Q. Let's look for the Q. So this is second. So now let's check if true and then true. If true implies true, then this is true. If false implies false, this is true still. If false implies true, this is still true. If false implies false, this is still true. Because based on the definition, the implication function will only be false if the first statement is true and the second statement is false. And therefore, we can conclude that the second statement is also a tautology. And now let's move on to the third statement. The negate of P implies Q and the negate P. So let's construct now a truth table. This is P, T, F, F, T, F, T, F. And now let's negate the P. Take note that when we negate the P, it is exactly the opposite value or the opposite truth value of whatever is the truth value of P. So the negate of T is F, negation of T is F, negation of F is T, negation of F is still T. Now let's move on to P implies Q. So let's now check. So T implies T, that's T. T implies F, that's F. F implies T, that's still T. F implies F, that's still T. And now we will negate whatever is the truth value of P implies Q. So the negation of T is F. Negation of F is T. Negation of T is F. Negation of T is F. Now let's identify the truth value of the last statement, which is the negation of P and Q, or negation of P implies Q and the negation of P. So what are we going to look for now is this one and this one. So let's recall that in AND operation, the resulting compound statement will only be true if both of the statements are true. So FF is F, FP is F, TF is F, TF is F. And now we can conclude that the third compound statement given in the problem is a contradiction. Finally, the last statement, P and negation of P and Q. So we already have two tautologies and one contradiction. So what could be our fourth statement? So let's identify, let's find out if it is a tautology or a contradiction or neither of the two. So let's construct now a truth table. P, Q, let's say P, this is T, T, F, F, T, F, T, F. Now let's negate the P. So whatever is the value, truth value of P, the negation of P is exactly the opposite value, the opposite truth value of P. So the negation of P is F, negation of P, F, negation of F, T, negation of F, T. And now let's move on to negation of P and Q. So let's look for the negation of P and Q. So take note again that in AND operation, the statement shall only be true if both of the statement is or both of the statement are true. So T and F, that's F. F and F, that's still F. T and T is T. And F and T is F. And the resulting statement, which is the P and negation of P and Q. So let's look for, or let's see P and also the negation of P and Q. So the T and F is F, the T and F is F, the F and T is F, the F and F is still F. So now therefore, the fourth statement is a contradiction because all of the statement, regardless or whatever is the valuation of each of the statement, the resulting compound statement is always false, then this is a contradiction. So the fourth statement is a contradiction. So that's all for my presentation, sir, for the tautologies and contradiction. Thank you for patiently waiting for my output, for my midterm output, and I hope that you have fully watched this video. And thank you for patiently waiting, and yeah, see you next semester.